वर्तमान में PS4 चरण का कोस्टिंग फेज जारी है। अब यान की ऊंचाई 280 किलोमीटर तथा सापेक्ष गति 7.18 किलोमीटर प्रति सेकंड है। अब यह उचित अभिवृद्धि प्राप्त कर पुनः प्रज्वलित किया जाएगा।
Vehicle performance normal.
The Aditya-L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere and corona, which is the outermost layer of the Sun. These payloads use electromagnetic, particle and magnetic field detectors. First among the 4 remote sensing payloads is Visible Emission Line Chronograph (VELC), which is a prime payload designed as a reflective coronagraph with a multislit spectrograph. This payload is developed jointly by Indian Institute of Astrophysics, Laboratory of Electro-Optical Systems, UR Rao Satellite Center, ISRO Inertial Systems Unit and Space Applications Center. The second payload is Solar Low Energy X-ray Spectrometer or SOLEX, designed to measure the solar soft X-ray flux to study solar flares. This payload is developed by UR Rao Satellite Center. Third payload is the Solar Earth Ultraviolet Imaging Telescope SUIT, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, LEOS, URSE and IISU. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer or HELIOS, developed by URSE. Is a hard X-ray spectrometer designed to study solar flares in high energy X-rays. The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short PAPA. It is designed to understand the solar winds and its composition and perform mass analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center. The seventh payload is a magnetometer or MAG developed by LEOS, which will measure the low intensity interplanetary magnetic field in space using a pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में नितभार के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन नितभार में सूर्य का प्रेक्षण करने के लिए VELC कोरोना प्रतिबिंबन और वर्णक्रम मापन के लिए है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप जो कि संकीर्ण और ब्रॉडबैंड फ्रीक्वेंसी में फोटोस्फीयर और क्रोमोस्फीयर प्रतिबिंबन, यह पैराबैंगनी प्रतिबिंबन टेलीस्कोप है। इसी क्रम में अगला है SOLEX सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर, जो कि सॉफ्ट एक्सरे वर्णक्रम मापी है, जो कि सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। इसमें HEL1OX हाई एनर्जी L1 ऑर्बिटिंग एक्सरे स्पेक्ट्रोमीटर है, जो कि हार्ड एक्सरे वर्णक्रम मापी है। इसकी अभिकल्पना सोलर फ्लेयर के अध्ययन के लिए की गई है। यथास्थिति नितभार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट, इसका उद्देश्य है सोलर पवन, सौर पवन में भारी आयंस, प्रोटॉन्स और अल्फा पार्टिकल का विश्लेषण करना। अगला है प्लाज्मा एनालाइजर पैकेज फॉर आदित्य। यह भी सौर पवन में उपस्थित कणों में इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। एडवांस ट्राइएक्सियल हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal.
यान पूरी तरह सामान्य, सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्दिष्ट कक्षा की ओर बढ़ रहा है। आदित्य-L1 के नितभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। विजिबल एमिशन लाइन क्रोनोग्राफ VLC इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप सूट इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। सोलेक्स और हेलियोस दोनों ही UR राव सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित किए गए हैं। ASPX और PAPA स्पेस फिजिक्स लेबोरेटरी VSSC तिरुवनंतपुरम द्वारा निर्मित किए गए हैं। और अंत में मैग्नेटोमीटर लेबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the low visibility region of the flight path, we take you to the discussion room where the key personnel connected with the Aditya-L1 will enlighten more on the payloads and details. Over to discussion room.
Welcome viewers. After India has made history with the Chandrayaan-3 moon launch, it has now set its eyes on the sun. These scientific breakthroughs back to back are like feathers on our country's hats.
Range operation
In
director.
fact, these celestial
As per
bodies
telemetry
are
station
very
deployment
important and are considered as
Loss of
sacred
signal
bodies
for
in
biaxial
multiple
shutdown.
global religions.
Vehicle is now
The
in
sun is the
non-visibility
central
period.
body of our solar
The
system.
non-visibility period
The
is
world revolves
approximately
around it
6 to 6
and it is a source of energy
non-visibility
for all
period,
planets including the
post-stage
Earth.
ban won't happen
Today
over
I am
the period
joined
of
by
next
all the
25
scientists who have
During this
played behind the
non-visibility
scenes
period,
to make this
ground
project a
trucks
grand
have been
success.
updated by
And I am
operators
Srinidhi,
on the
reaching
video
out to
hall.
you from the
Flight
Satish
parameters
Dhawan
will
Space
not be
Center,
updated. All stations,
Sriharikota.
executives and visitors
And
are
today we'll be
requested to
discussing
in position.
about the impact and the benefits of the Aditya-L1 space mission. So today we are joined by Dr. Anil Bharadwaj, Director of PRL, Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics, Dr. Sankara Subramanian, Principal Scientist of Aditya-L1 mission, Dr. Durgesh Tripathi, PI of SCYT, Dr. Dipankar Banerjee, Director of IRIS, Nainital, Dr. Satish Thampi, PI of PAPA,
That's 25 minutes.
and Dr. Vipin K. Yadav, PI of Magnetometer, joining us today for a 25-minute fireside chat on the sidelines of Aditya-L1 launch. To start with the principal scientist and PI of SOLEX, Dr. Sankara Subramaniam, why is Aditya-L1 mission so important and what are the objectives of this mission?
Thanks a lot. I mean, first of all, let me thank ISRO as well as the Government of India for providing a great opportunity for the solar and heliophysics community of the country. Both solar, heliophysics as well as astronomy thrives on data. More the data you have, we get more understanding about the system. And sun is our own star, our dearmost star, so understanding them is much more important for our everyday life. So this mission, Aditya, when it was conceived initially, with a support from our Professor UR Rao, along with Dr. Srikumar and Professor G. Srinivasan, we made sure that we will have a unique data set which is not available from any other missions internationally. So the 7 payloads, what was conceived for this particular mission, will provide a unique set of data which is currently not available from any other missions, which will provide us new insight into the solar and heliophysics community in India, and provides some important aspects like the initiation of the coronal mass ejections, the speed at which it gets initiated, and some wave bands which are very important for the Earth ionospheric connections, like near ultraviolet band, and the high energy particles, which is high energy radiations, as well as particles which is coming from the solar flares and coronal mass ejections. So these are the informations which would be available from this particular mission, which will allow us to understand the sun, its dynamics, as well as the inner heliosphere, which is an important element for the current day technology, as well as the space weather aspects of it.
Thank you so much for your remarks, sir. So now we'll move on to Dr. Anil Bharadwaj. So the sun is a very important energy source of life. Having understood that, it creates a trouble when it's angry. How does Aditya-L1 helps us through the mission?
Thank you and good morning, viewers. First of all, let me tell you that Aditya-L1 is a multi-wavelength, multi-instrument and multi-directional mission. Multi-wavelength because it works in X-rays, UV and visible. Multi-instrument because there are 7 experiments on board. And multi-directional because it looks not only in the sun direction but also around it. Now when the sun becomes angry, there are 2 types of process which happens. One is solar flares, that means electromagnetic radiation, which reaches the earth in 8 minutes. But along with that, there is a mass which is also ejected out in form of plasma, and that can take about 2 to 4 days to reach the earth. What we are looking for from the Aditya-L1 mission is to see the impact of solar flares as well as coronal mass ejections as they come to the earth. We have instruments which look at not only in the sun direction, but also in other directions, for example, perpendicular to ecliptic or in the earth directions. The impact is that we need to see when the sun becomes quite angry, what are the ways in which it is affecting the planet Earth, and L1 point being at point L1, which is just 1% away from the Earth, it is able to provide us a lot of new informations of the plasma and the electromagnetic radiations which is reaching the planet Earth.
Thank you so much, sir. So now we'll move on to Dr. Annapurni Subramaniam. So the science behind this mission is very unique. So what's the impact of this on the Earth and also on the heliosphere?
Yeah, so thank you for having me on this show. To put the thing in context, I'm the director of Indian Institute of Astrophysics, and we have delivered one of the major payloads on this mission. This is the visible emission line coronagraph. So if you actually look at the words used in it, it is visible because it is seeing the sun in the visible wavelength. Emission line, so what is it detecting? It is the emission line of certain elements. Because the corona is hot, the emission which you get is in the terms of, it's not absorbing the light which is coming from the sun, but it's already hot, so it is coming down by emitting lines. So we are tracking these lines using what? A coronagraph. Now what is a coronagraph? This instrument makes a total solar eclipse all the time within the instrument. So you are looking at the sun all the time, 24/7 through using this mission. And this instrument looks at the sun as though it is always in total solar eclipse. Now, why you want to have the eclipse all the time? Because you want to see the corona. Why corona? Because when sun burps, when sun is angry, the corona is what it takes the matter away. Now, what is unique about this instrument? This is going to see the corona as close as possible from the disk of the sun. Now, what is so challenging about it? It is because the sun's corona is 1,000,000 times fainter than the disk of the sun. So you have to not see the disk of the sun, but see only the corona. So